Assalamualaikum and welcome to the video. I am Muhammad Hafizul Hafiz bin Husin from Physics Unit KMPK. I would like to welcome you to the video series and most important of all, welcome to this amazing college. In this video, we are going to go through Experiment 1, Measurement and Uncertainty. Make sure you have your jotter and manual ready. You will need your jotter for taking notes as you follow along with the video. The learning outcome of the experiment is that you need to be able to measure the lengths of various objects and determine its uncertainty. Uncertainty or doubt of measurement can be understood as follows. Let's say you are trying to measure the length of the leaf. The ruler has a resolution of 0.1 cm. Resolution is the smallest increment of the measuring instrument or the smallest division on the scale. What would be the length of the leaf? You are sure that the leaf is at least 3.5 cm. You are pretty confident on that. But as you can see, the end of the leaf is not exactly at the 3.5 cm mark. We cannot really tell for certain the length of the leaf. So we are going to estimate the length of the leaf. We estimate the length to be about 3.5 cm. The reading is actually at the interval between 3.5 and 3.6. This interval is the uncertainty of measurement. We are going to report the length of the leaf as 3.5 plus minus 0.1 cm. So when other people see the reading, they know the value are estimated closest to 0.1 cm. So, when reporting the measurement, we will write the value of the measurement as our best estimate plus minus the uncertainty. If x is the measured physical quantity, then the value of x is written as x plus minus delta x. The delta x is the uncertainty of the value of x. So, every measurement that we make in the experiment has some degree of uncertainty. As we have shown before, the uncertainty is due to the limitation from the resolution of the measuring instrument. Instrument with better resolution is able to produce measurement with higher precision. For example, if we take the vernier caliper, the resolution is 0.002 cm. If the caliper is used to measure the length of the leaf instead of the meter ruler, the reading will be much more precise and we will have a much lower uncertainty. The uncertainty is going to be 0.002 cm. According to Stephanie Bell, the uncertainty tells about the quality of the measurement. You can pause the video and you can read the definition given by Stephanie Bell on uncertainty of measurement. I hope this has given you some ideas on what uncertainty is and why it is very important when making and reporting measurement. Coming back to the learning outcome, now I am going to show you how to determine the uncertainty of measurement. We are going to discuss how you can determine the uncertainty for 1. Single reading, 2. Repeated reading, and 3. Combination of uncertainty for a derived quantity. Moving on to the first section, uncertainty of a single reading. The uncertainty of measurement is determined from the method of reading. Either you have a single point reading, 2-point reading, or vernier scale reading. For single reading, the uncertainty of measurement is taken as half of the smallest division on the scale. Example of the instrument are ammeter, voltmeter, and thermometer. For a 2-point reading, the uncertainty is taken to be 2 times half of the smallest division, which is going to be equals to the smallest division from scale. Example of instrument are meter ruler and protractor. Finally, we have vernier scale. The uncertainty is going to be the smallest unit on vernier. Example of the instrument are vernier caliper, micrometer screw gauge, and traveling microscope. The easy way to know whether you have a single point or double point reading is that if the zero of the instrument is automatically lines up, means that the instrument is going to give you a single point reading, as in the case of a voltmeter. If you look at the resolution of the voltmeter, the resolution is 0.1 volt. The uncertainty is half of the smallest division, so the uncertainty of the instrument is 0.05 volt. If you have to manually align the zero, means that you have 2-point reading. If you look back at the examples where we are trying to determine the length of a leaf, first we need to align one end of the leaf with the zero on the meter ruler, and then we have to estimate where the other end of the leaf on the scale. In this case, the estimate is made twice. That is why uncertainty is 2 times the smallest division from scale. Here are some of the examples of the instrument. Let's look at meter ruler and ammeter. Meter ruler is 2-point reading. The resolution is 0.1 cm. The uncertainty for measurement for the meter ruler is 0.1 cm, which is equals to resolution of the instrument. In the case of the ammeter, the zero is automatic. Thus, we have a single point reading. The resolution is 0.02 milliamps. The uncertainty of the instrument is half of the resolution, 0.01 milliamps. For vernier and micrometer screw gauge, the uncertainty is just going to be equals to the smallest unit on the scale. We recommend that when you write the list of the apparatus, go to the measuring instrument in the list and write the range and the resolution of the instrument next to the instrument name. You can get both of the value from the instrument itself. Here are some examples. Next to the instrument, we write the range and the resolution of the instrument. Look at how the value of the length of the book and the current is written. The measurement value and the uncertainty has the same decimal point. The percentage of uncertainty can be calculated using this formula. The uncertainty of measurement over the value times with 100%. We want the value to be small. Remember when I said uncertainty tells about the quality of measurement. The smaller the value of the percentage of uncertainty, the better the measurement. That is it for a single reading measurement. Now we are at the repeated reading section. We want the uncertainty of the measurement to be small. In order to do that, we are going to do a repeated reading. In repeated reading measurement, the value of the measurement is the average value of the reading plus minus the uncertainty. This two formula is going to be used to find the average value and the uncertainty of reading. I'm going to show you some examples on how to use these two formula. In repeated reading, we are going to use table to record the value of the measurement. On the left, we have reading from an ammeter. The uncertainty of measurement is recorded at the very top of the current in circuit column. The value of the uncertainty is 0.05 ampere. This is for single reading uncertainty. To better improve the uncertainty, we repeat the measurement of current 5 times. First, we calculate the average value of current. We add all the value from the reading and then divide by the number of readings. We get the average value of current to be 1.54 amps. Next, we want to calculate the uncertainty for the measurement. We are going to use this formula. On the third column, we find the difference between the average value with each of the reading. And then we add all them up and then divide by the number of reading. This gives us the uncertainty for the current. We get the value of 0.032 amps. For the uncertainty, we have to round up the value to one significant figure. You have to remember this rule. So the uncertainty of our repeated readings is 0.03 amps. This improves the uncertainty of our reading from 0.05 to 0.03. The percentage of uncertainty can be calculated using this formula. 0.03 divided by the average value of the current and then times 100%. The percentage of uncertainty that we get is 1.94%. After this, we are going straight to the procedure. So I want you to pause the video, go to the procedure section of the experiment, read through the procedure. After you have read through the procedure, you can come back again to the video. Hello, welcome back. If you have read the procedure, this statement will make sense to you. The first part of the experiment, you are required to choose appropriate instrument to measure the lengths of various objects. Now I'm going to take you to the video showing all the instruments that you are going to use in the experiment. The first instrument is a meter ruler. It is a 2-point reading instrument. You are going to use the meter ruler to measure the length of the laboratory manual. You are going to measure the length across the width of the laboratory manuals. You are going to get 5 different readings. Next, we have a vernier caliper. You can open the box, take out the caliper. First, check for the zero error. You have your main scales and then you have your vernier scale. We are going to use the vernier caliper to measure the diameter of a coin. Next, we are going to use the same caliper to measure the diameter of the glass rod. This is the main scale, the rotating scale, the thimble and the ratchet. You are going to rotate the thimble until the spindle gets close to the anvil. When it is close enough, you are going to use the ratchet to close the gap. Check for the zero error. You are going to use the micrometer screw gauge to measure the diameter of the ball bearing. When the spindle gets close to the ball bearing, use the ratchet to close the gap. When you hear a click, you can lock the micrometer and you can start taking readings. In the second part of the experiment, you are going to use the traveling microscope to measure the internal diameter of a capillary tube. We are going to introduce you the traveling microscope and how to properly handle them. Let's go to the video. This is the traveling microscope. You have a microscope on a rail mounted on a very rigid bed. This is a side view. The focus of the microscope can be adjusted by turning the knob on the side. You can secure the microscope to the horizontal rail by tightening the screw. This screw on the side is used for fine adjustment. It will move the microscope along the horizontal rail. When you turn the screw, you will see the scale moving. You are going to use the magnifying lens to get the reading from the scale. The vertical rail can also be used to make adjustment to the position of the microscope. You have to place the capillary tube right under the microscope and bring the objective close to the capillary. You can further fine-tune the position of the objective using the knob on the side of the microscope. Look through the eyepiece and adjust the focus until the image of the capillary can be seen clearly. Adjust until you get this image. Record initial reading. Turn the screw on the horizontal rails until the crosshair gets to the other end of the capillary. Record the readings. The difference between the two readings is going to be the diameter of the capillary tube. You can repeat the measurement by bringing the crosshair back to the initial position. Record the initial readings and then record the final readings. And then find the difference. You get the diameter of the capillary tube.